Hello everyone and welcome to this video where we're going to talk about combining an ROV with a coaxial helicopter. Now, sounds like the beginning of a joke. A coaxial helicopter and an ROV walk into a bar. Well, pretty much you can imagine what you get if we pair these two together is a flying drone. Now, I've been wanting to make a drone here for a long time because there's so many applications for OMA, even transport implications, and I didn't want to do it because I don't like how large the rotors are. I mean, I like how large they are for helicopters. They're just too big for a drone. I wanted a drone that was going to be more or less the size of the ROV, propellers and all, so it can be stored as a Unicon container and all this other stuff. Well, this configuration of the rotors actually more or less is making that possible, because previously I thought I had to have a quadcopter with 4 of them, and where on earth would you put them? Well, with 2 of them like this, you can put them and you can have the full range of maneuverability and all that good stuff. Boom, that's it. We're done. We have a drone, we have a ROV and a helicopter and everything. Just kidding. That will never work, but that gave me the idea of trying out a simple Unicon style platform with just these rotors to see what happens. Now, these are the smallest sized rotors here, and eventually what I do want to do is make sure that the ROV system that I've developed and placed in the Unicon container format, this one, can also fly the drone. How cool would it be for compatibility to be able to fly a drone using this same interface and then changing the channel and then controlling an ROV as an underwater exploration vehicle? So I'm thinking if I can utilize that, that would be the best. Now, spawning this thing in just to see if this small electric motor with 2 gearboxes is enough to power this. Alright, well, definitely is. I don't know if it's a weighting problem or not, but it is flying, so that's always a good thing. But of course, the propellers were all in the same direction. Anyways, we had liftoff. That was what is very important for us there. Now, I need the coaxial helicopter, because what I'm going to do is take its little brain and orientation and everything and make things work. So, first things first, these have to be rotated. I'm going to spin them around so the orientation matches. Now, in this case, the top one is a positive arrow to the left, so only the top one. So I can take this one and flip it like this. Alright, so now that orientation should hopefully work. Of course, we have a bunch of different parameters coming in here. There's top collective, bottom collective. Pretty much this microcontroller for the coaxial helicopter is what I have to put in here in order to even get this thing off the ground in a in the right manner. Otherwise, we will just end up having it more or less flop around, and that's not what we want. Now, I did throw in the ROV microcontroller here. This is a very advanced microcontroller. If you watch the videos, you will know the amount of effort that went into creating this. I'd really prefer not to create it all over again, especially because it communicates with this system. But if I can just make minor changes to it, then that will be the best case scenario. But now that the test was successful, what I actually really want to do is, before I get into anything else, remove this. Well, actually, we can see what, if we need 2 gearboxes or if 1 is enough, just because that's going to determine how compact this thing goes. Let's see. Oh, first of all, we don't have the collective on. Try that again. And it does take off. Alright, so that is good. So we don't have to have more than that in here. just the one single gearbox and the one single motor. That'll also, well, we'll see if that works or not. We could always add more gearboxes, and also batteries are in high demand. In order to make this thing work properly, we'll have to have batteries charged up and all that good stuff. Now, I can remove what I don't need and start to move over things from the ROV, so I don't have to replug all this crazy stuff, because right now we just have the two microcontrollers. But now that I know that it can fly and that I have the space, we can start to extract elements from here, move them to here, and get ourselves working with parts we need. Now, we don't need things like the arms, we don't need the welders, so there's stuff that we have to just scrap, and I'll see how we can put it here in the interface. So there are certain things like the cameras and the lights that I do want to just take directly from here. Makes the most sense. So that will be very good for that. We'll have to put lights as well, and there's other things like depth meters and whatnot. Now, the depth meter is also an altimeter, so that is still useful to have in the drone version. Now, this may be an ugly box-like drone, but once I get the microcontroller down, it can always be reconfigured into something a little prettier. Like, I do like the look of the ROVs, and I want to kind of keep that same style. I don't want to have it look brutally out of place. But let's worry first about the functionality. So as we continue on taking out things, we will see that there's going to be conversions. So for example, where we have the fin rotation, that's going to be our pitch, right? Where we have previously the ability to go up and down with these bottom propellers, that's going to be our collective. So I'm trying to convert, in essence, this into this while retaining the same style of control. Now, I saw a really nice example of a drone on the workshop, but it used a bunch of XML modded parts, and my personal thought was I was going to try to prevent that sort of thing and actually make something more or less out of vanilla parts. I may XML mod the propellers or the rotors to be a little smaller. We'll see how that all plays, but that's probably the only thing I would really XML mod. Everything else would remain. The nice thing about the microcontroller I developed is that it can easily be switched up for whatever we need. So for example, we want lights, but we don't need a whole secondary MC, so I can go ahead and remove that. And then in here, once I just find my lights, that can go attached to here and here. And this whole secondary one that was attached with the composite, I no longer need. So that's kind of nice. Also, we had a whole other microcontroller for dual control, meaning if we wanted to use it as a plugged in with the charging port, or if we want to use it as just the remote version. Now, of course, this is an ROV. I don't think I'll be using it plugged in, but a winch, also, I guess using a winch and giving it unlimited power is kind of appealing, I gotta say. So maybe I leave it for now and we'll see, because like if I put it on a ship and put a large winch and have it in essence so you can go up and scan the area, but you don't have to have a limited battery supply, that could be kind of neat. And then we have the pivot for the camera right here. This one's not even used. So just a couple little things like that we can continue to take over, and that should in essence conclude just basic copying. Now there will be a lot of other elements that have to go into the microcontroller, because it will never be a simple one-to-one microcontroller, unfortunately, and I think that's kind of the bulk of the work I have here. in the seat here, when you're sitting, it says that we have AD is steering, we have throttle, we have thrust up down, we have pitch, but there's going to be some other things we have to put, because thrust up down has to also be our we have to put pitching, yawing, so the various different types. I may have to just revamp what the seating controller there says, but regardless, it should be pretty straightforward to convert and drive a ROV and drive a drone. Probably the easiest one to start with is A and D, which is steering. In the case of the helicopter or the drone, it will be the roll. So the roll in, and we have these guys there. So whatever we have, let's attach, just copying what this is. So there is top and bottom collectives. So roll on the top, there is top collective, and there is bottom collective. And then this one here, we also do have to put a gyroscope. So I didn't make room for the gyroscope. That has to fit in this thing as well. So let's grab one of those, and that is a little larger. And the rest connects to that. So we have roll in, which will come from the stabilized roll. Collective in, which comes from the stabilized up down, and yaw, which comes from the stabilized yaw. Also, you'll see that the stabilized roll goes to the bottom propeller's roll. So roll and the roll here. And there's probably a couple others. So pitch goes to both of them without anything else. So that's easy. Pitch and pitch. And I think we have one more remaining. No, we don't. So that is it. All three of these are connected, and all of the parts of the gyro are connected. Now what is not connected is the input values. So that's what we're going to have to play with. Everything else here is already connected, and we'll have to have this thing on. Now, I will need a proper on button, presumably, especially considering there's other elements like the altitude sensor and stuff that I don't want them to be just permanently on. So we'll have to turn on the thing, whether it's with a key or with a button. We'll see. So extracting the ROV microcontroller here, just to give us an idea of what is still attached to the hulk, or the husk of it, you can see we have the motors, rudders, pitch. So the motors, that's one thing I have to kind of work with, because the way they work is they stabilize the whole ROV when you're going up and down. So each one's attached separately. All we need is one single one to operate us going up and down. And we have the throttle. Now throttle is going directly to pushing the thing forward. So all of these have to be converted to the seat. Now, easy one to start with is A and D. In the ROV controller, AD is steering, and over here, AD is roll. So steering equals roll. So the steering rudders goes to the roll node there, and then we don't need any of these, and this actually turns off the bulk of what I currently have kind of going there, just to not cause any confusion. All right, next one. The side thruster motor RPS we don't need, because that's pushing the thing left and right. In essence, that's yawing it, but we're not going to use number keys 1 and 2 for yaw as we have here and here. So this is yawing. So we're going to use something else. Now if we go look over here, we can go to W and S, that's pitch. So over here, our W and S is our throttle. Now it's sticky here, and here it is not sticky. So this may cause some problems now. So of course, inside the seat microcontroller, I can make the adjustment and have it such that it goes and uses a counter which is probably what I'll have to do. But for the purpose of this exercise, I'm just going to set this to reset. In this case, throttle out is equal to our pitch. Up down in the helicopter is the collective. Up down in the ROV is the pitch. So that means the pitch, which is going to these ones here, is going now to our collective. Left or right in the helicopter is the yaw. Here it is the cam-eye, robo-arm, and thrust up and thrust down. So that is what is controlling all of these motors that you see here. And if we had our other system, it would be controlling our robo-eye and whatnot. Now, because I don't have my secondary MC and I don't really want to put it, I can see what we can do. So we may have the camera mode rotational speed or something like that I could kind of piggyback off of and make that become that value. Alright, so the thing seems to be on. We're on channel 1. And if we go here to channel 1, first things first, we're getting a bunch of nothing static here. The camera feed was not attached to the video transmit because I had the two cameras in here previously. Alright, well, that's a start. We see the ROV view at a very basic level. That is good. Alright. Last but not least, on this on-off button, that is what's going to turn on our little electric motor. So it's just a simple numerical switch box there. Alright, everything's up and running and paired. If I press this, oh, and we're up. We're very, very up. And that is because I did not change it back to neutral. Alright. Try that again. Turn this on. Alright, now we're hovering. And if I use this, I can go up and down. Well, I'm not going down. I'm keeping going up, even though I'm trying to press down. So that may be an issue, but I'm able to roll. Am I able to yaw? No, not really. So there's definitely some things I have to work on, but the overall idea does seem to be working. So we did take off and gave it some control elements. We're so close. Like, I really think that it would be advantageous to not have a separate drone and a separate ROV interface, as much as it would probably be cleaner and nicer and easier. I just do like the idea of being able to plug them both into the same station. It may require more work than I thought, because it seems that I did not, for example, account for a negative value to go on the up-down. Like this pitch, it doesn't seem to be registering a negative number here in the ROV itself. Well, when in doubt, displays. So let us put a couple of different displays and a couple of different information here. So going here will be our up-down. So this is collective. Now I won't be able to read them, but at least I'll have an idea of where they live. This one will be our yaw. That one's not that important as long as it works. And I think our roll and our pitch was also working. So we'll just see this is the roll and this is the pitch. So I have the biggest issue right now with my collective. So right now it's going up. If I just take a little pause, you could see that we have a collective of 12 or 0.12, where I don't really think I want one. Now if I do press the down key and I pause it again while holding the down arrow key, what does our drone give us now? Still the same 12. So it seems that that value isn't actually changing, and that's why it's constantly going up. So it's not, maybe it's just not attached properly in this microcontroller. That very well could be it. Yeah, because I had cam eye, robo arm, and pitch. So the pitch is automatic on the ROVs. These things automatically balance out the pitch, so I can't have that that node attached to what I need here. So it's the collective that is being problematic, and it's right now coming from the pitch side. Well, that would be it. Again, pitch is automatic, so that doesn't make any sense. So I can take this up down, and let's try attaching it to something else. Robo arm up down, robo arm left right, sliding track. Oh, I see. So I had the robo arm up down and robo arm left right. Now here it's thrust up down, but I'm assuming that left right robo arm and up down robo arm are these commands. So that would actually make more sense, that my up down on my robo arm would equal the up down on the seat. The only thing is though, the robo arm has a max amount that it can open. Like, we're stuck on a pivot, so I don't know if it maxes out and no longer moves once it hits a certain number. So that's something I have to now dig through this to find out. But you do see that I have my rudder, my rolls, and they're all automatic, so none of them are actually being utilized. Yeah, you see, robo arm left right, robo arm up down, they all are fed by a threshold coming from there. Like, what would honestly be probably easy is, in parallel to all this stuff, if I just add a second line, and if it's a helicopter, then do the pitch. If it's ROV, do the robo arm, that type of thing. So I'll try to add drone collective, drone yaw, and those are going to go into these things here, because you see the steering rudders are directly fed from channel 1. Channel 2 goes and feeds the throttle out. So those are also something we may have to take a look at. But 3 and 4 go into this series of craziness, and it may be as simple as just putting them to be fed by these values. Over here, value 1 is AD, value 2 WS, 3 is left right, 4 is up down. So with that in mind, if we jump back into our microcontroller here, that's going to explain a lot here. So what we do have now is a series of various things, and to be honest, maybe the easiest thing would be just to add all 4 of these components. Granted, some already work, but it may be easier for tracking purposes in the future. So we have our drone collective, drone yaw, drone pitch and roll. So roll and drone pitch. Now with these values, just drag them from kind of the abyss over here and put it here. We'll put them right there. All right, so what do we know? We know that we have these values here and we have these nodes there. So when we talk about having a AD, which is equal to value 1, so AD, that should be our roll. WS is equal to pitch. Left right is yaw, up down is up down, collective. So those are kind of our standard helicopter controls. And if we jump back into this, we'll be able to connect everything. So those now seem to be attached. Everything is attached to their respective nodes. And what we can remove is something like the front motors, left motors, all this stuff. This is definitely not used at all, and I can go ahead and fill these values in there and now reattach them to where they had to go. So previously we had drone roll, that's going over there, but now we need the drone roll to go to our roll. Here we have collective, and we'll attach it to the up down. We have yaw, yaw, pitch, pitch, and that should give us a little bit better values. Now that's still 50. So that's interesting. We'll have to kind of see how that all works. But if I turn this on and pause it, well, now it's telling me 15 is on the collective. Okay, if I press the down arrow... Oh! Alright, well, it actually did work. It actually did slightly go down and then crashed as well. So, do I have a really high sensitivity here? All are reset, some are relatively high sensitivity, so we'll have to kind of see how that all plays out, because we can't change these values within the seat when it's spawned in. So something like that would be easier to make a version of this that's purely for the drones, which I still might do if I get tired of this, but you can see that overall it seems to be working. Which really means that all we need is fine-tuning to get this properly kind of working rather than what we had last time. So, alright. That was me just trying the collective up-down, and it was sort of going up-down and then it went nuts. I want to try this outside because here we're not going to get it caught up on the ceiling. So in this case... Oh, so the collective really does mess with it. Okay, now we've stabilized ourselves. Alright, so that is me pressing AD. Alright, so that seems to work nicely. If I press the... Oh, okay. So the gyroscope goes nuts and kind of saves itself, it seems. Potentially. Okay, we can pitch it forward, so WASD seemed to be working nicely. No problem there, until it goes nuts. Okay, that's good. And then, last but not least, if I could just stabilize it out, can I... Yeah, I can. Okay, so that's actually me spinning it around on the spot. That's the yaw. So really, everything works except for the up-down. Now, for something like this, again, my go-to is always add weight, because I always feel that something is not working properly due to the weighting issue. So I'm going to add some weight blocks here. Those would be better to be batteries, so I'll see how that goes in the future. And what I can do also is tune down the gyroscope. So you could see we have a high max throttle, which might be causing it to kind of go crazy with the collective, and our yaw also reacts quite quickly, so I can just tune everything down, make it a little more less sensitive. Also interesting is that we kind of have a default pitch of 0.15. Maybe that's coming directly from this microcontroller where it's set to like prevent the ROV from going up, so it could be like just a default pitch setting that I really have to kind of search through here, but we do see that once I find the seat, it should make a little bit more sense. Okay, in my seat, it seems to go directly into this, which writes all these things, goes here, and goes there. So there's not a logical reason unless there's no trim here either. So it's still hanging out at 0.4, and now it's dropping down. Now if I just watch it carefully... Oh. Okay, well, is that then to do with my microcontroller here? It shouldn't be, because this only converts my collective into the top and bottom collective. It doesn't do anything else. And what we're reading here is directly the stabilized up-down coming out of the gyro from our drone collective node in the microcontroller. The only thing I could think of is that this is way too sensitive, and that's why it's causing this. So if I turn it down to 10, does that work? So it seems to be going up and down. Oh, but it is freaking out a little bit. Overall, that is much better. Okay, good. And the yaw is working much nicer too. Cool. Now it seems we're constantly going up. So like I do have to put a bit of a trim. And now that prevents it. It's not going up all the time. In fact, now it's going down. So to make it stable, I need that trim. But it seems that there's just like a set value kind of popping out all the time. Now that's going to cause it to freak out. But yeah, like right now, if I run over to it, it's going to be telling me, alright, it's at 0. So and then it climbs. So it actually did climb up. I'm holding it at 0 and it went to 1.5. Or rather, 0.15. But that's the cause of it constantly wanting to go up. It's always at a positive collective. Very stable though. Very happy with kind of the controllability of it. One thing that I must consider is maybe it's not me applying an upward thrust, maybe it's the gyro doing it by itself. So this drone collective, if I take a look at that, what will that be? Because keep in mind, our auto hover is in essence what was causing this. So if I do this, and now, so I'm able to control that, it wants to go up. Alright. So that changes things. It seems the gyro is forcing it to want to be kind of moving itself upward. Good to know. And now comes the time for the decision. Either I keep the drone on the ROV system, and rather than calling it an ROV controller, I have to call it, you know, something similar and kind of rename things here and there. I think it's probably more worthwhile just to make it its own separate system. It'll function better, it won't say seafloor, it'll just work and be better altogether. So I think that this is a good start, and I think that with a little bit of effort I can make this fantastic. But like even here, like these buttons and things don't make any sense, and just having depth and seafloor don't make sense either. So it's a very useful system, and actually it can end up being quite powerful in the right hands, like once I stop the shaking. But in essence, you know, you can use this for search and rescue purposes, you can use it for all kinds of things, and all I have to do is some minor modifications, and I can end up with a really neat drone. So to kind of change this ROV flip, to change a bunch of the settings that I previously have, don't make much sense, especially because ROVs and drones are kind of in their own different subcategories. They're not really similar. One goes above, one goes below. So there are similarities, but they're not the same. So anyway, this is actually a very good start, and I'm very happy with this. So now with that in mind, that actually makes it a lot easier for the seat. Like I can change a bunch of this stuff up for their proper names, and then I can actually take this microcontroller and this one and make it work properly for the actual problem at hand, rather than making it adaptable but, you know, piggybacking off another system. So now easily things previously that say ROV can now be renamed. Things that make no sense, like the seafloor, can be changed. The ROV flipped thing doesn't make any sense at all, and it can be changed, stuff like that. It was a good exercise though, because if it was more compatible, you know, it would probably be a direct one-to-one swap. But in this case, it doesn't seem to be so, and I think it doesn't make sense to have it tetherable, so that will also be removed. It only can be battery powered and controlled remotely. Otherwise, we're stuck kind of not really flying high and whatnot, so I think that can easily be changed. It seems to have a decent battery life from what I saw up there. Interesting enough, I turned the throttle down, so now it actually has a throttle of 0.3, and not only will that make the battery last that much longer, but it also should help stabilize the thing. Now that's assuming I can take off, but somewhere in that range I have to find the bare minimum collective that I need to be able to gain altitude. So 0.3 seems to be too low. Let's try 0.33. Okay, 0.33, we're up, we're forward, and we're away. Now I have to keep in mind that with the draining of the battery, it may get to a point where like 50% and it can no longer fly. So I just have to make sure and be careful that while remaining with the proper throttle, it can still do its tasks. Like you see, it's climbing quite slowly now, and soon it's not going to climb at all, and I'm still holding up. Yeah, so it's really stalled out. Now down. It can go down. If I press up, yeah, it shakes. That's fine. So anyways, some fine-tuning has to be done in this controller as well. Things like this doesn't make sense that W is operating that when I also have pitch. So that graph should be my up and down throttle. So like this is my collective up and stuff like that. Anyway, the battery seems to be okay. For the two batteries, we're at 96 now. So that's not terrible at all. As long as it flies, right? And there it is, looking down at me. So, quite a nifty little contraption. And seems to be pretty stable. Other than a little bit of shakes, it seems to kind of work quite nicely. Overall, it is awesome having a view like this, and what I'm going to do is, instead of like cam eye, robo arm, whatever, this camera itself will be zoomable, night vision, and rotatable, so you can aim down and stuff instead of having two cameras. This way you just have the ability to like tilt it down rather than pitching the whole thing forward. It does seem to, even with the throttle turned down to like 30, it still seems to shake. I just can't get away from those shakes. So if we go ahead and fire it up, and we will get into this. Now keep in mind I just set a trim, and hopefully that trim prevents the thing from taking off, even though I can't see that working like that. If anything, the trim will keep it going up. Yeah, I set it in the opposite direction, this trim. But it seems to be much more sluggish, so right now it's even not taking off. So there's some fine-tuning that has to be done. Even at like 50%, it seemed to work kind of okay. And what I will need to do is, because now this will not be a ROV, it'll purely be for the drone, I have to make position hold and altitude hold systems built in. So previously we don't have that, and it seems to be fairly stable. Like, I really do think that it looks to be quite stable. In this case it's dropping, so I did make the trim too much. But regardless, I think having a good altitude hold and position hold will still be very useful for this system, just to allow us and ensure us that we can use it in a storm and such things, like if it's windy and whatnot. Because I'm sure if I turn the wind on right now, it will push my little friend away. Yeah, there it goes. Not too much, but it's being pushed nonetheless. I did put a larger set of antennas here next to me, and hopefully this allows, you to fly away to some extent and explore things. You could see we are hitting just over 400 meters distant, which is awesome, and we still have 90% signal strength. Oh, see, and that is kind of some of the downsides if the thing goes uncontrollable and starts to flip. But we will sort through some of these bugs. I think I busted one of the rotors because it's dancing around like there. Some very simple tweaking, obviously renaming buttons and such, but here now you can see that it's much more cleaned up. And on the right hand side here it shows sort of the collective going up and down. I will add a line through that point because that's kind of like zeroed. But you can see here when we give it upward collective, that number increases. And you can see it on the far edge of the screen here as well. So that's nice. And I just kind of cleaned this up, put elevation. Now down here I have the camera mode, and we'll see how that all works. Technically it's supposed to adjust the camera, but there is some work I still have to do on that, you could see. Anyways, it is facing down, which is nice. The lights do work. I will have to remove the robo arm. Really, it's just camera mode, and then I have to have night vision mode, and I don't know if I'm gonna have it so it's zoomable, or you just press a button and it's just gonna zoom in like 50%. So you have the two modes. You have either zoomed or not zoomed. And now the infrared mode and the zoom mode work. So they just kind of work. Either it's not zoomed or it's zoomed. And it's not a huge zoom, but it does give you a bit better view. Now I may change it and make it a little more. Like this is a good kind of more or less wide angle shot of what we see. Whereas this one, I guess we could go a little more. Anyway, you do understand the point. So we do have all that. The camera mode I have to figure out what's going on, and the robo arm I just have to remove. I've made some breakthroughs for the stability. I put everything here around 80%, giving myself also a minimum throttle, and the seat itself, I brought the sensitivity even lower, so it has an even slower kind of molasses-like changing of things. And in addition to that, everything's labeled drone. The button now turns on the thing. The key turns the station on. And you can see here, it does work a little slower, but it's not shaking as much. And even if I just kind of fly, we gain around 25 knots or so. You could see it kind of moving forward. And if I let go, let's see what happens. Previously, this is when it crashed. It just kind of seems to glide. So that's really nice. The zoom mode, I kind of made it a little stronger so you could really see it zooms in, which is nice. And otherwise, the system seems more or less stable. I will give it some more troubleshooting, but slow is okay. We don't need it to be a fast drone, just more like a viewing drone. Now, one thing that I do have to do, like I said, is the altitude hold. I think I'll have it automatic, so when you're not pressing the buttons, it shouldn't be changing altitude. That's kind of not a good thing. Position hold, I may not need, just depending on kind of what I end up trying to do, but I could always make it this because I have the mode selection, and then over here I have all these other things. So one of the modes could just be position hold. Right now I have attachment because I'm thinking like a future type of thing could be something like transporting something and dropping it, or just kind of an empty button for other things, other features, but I'll see if I end up using it like that. I was able to clean up and remove a bunch of things on the drone operator microcontroller, so I may end up reducing the size of it just so it's a little more compact. Right now there's a bunch of open space. My preferred way of doing that is to have one version here where I pretty much move things around as I'm doing here, and then another version that I'm able to keep in its regular form. So you see here now, having moved around a bunch of stuff, I lost a lot of my logic, but then I could just refer back to this one and see where everything goes. For example, RC mode active, I can find that here, and that's attached to these two things, the transmit and the backlight, so stuff like that. So that should be it. Now we ended up like making it 2 blocks narrower, which also makes it a little cheaper for one, but for 2 it just makes it a little easier to hide and stuff. So if I turn everything on, we'll see the moment of truth. So still not working. Whereas if I turn this guy on here, oops, something is not right. And there we have it. So with the compact version, everything works. I just had one of the frequencies actually on the wrong spot. So in this case now I'm able to have it in the right spot, and it seems to be working just fine. On the controller side of things, I think it's pretty well handled. Not only does it kind of look good, it seems to work quite properly. So now what we have to do is tune up this monstrosity, starting with, of course, the camera, aim, and all that good stuff. Using the same approach, I was able to get the drone microcontroller 1 block smaller, so not as much, but still saves some space and just makes it more compact and kind of smart. Now, what I did not do is actually change the guts of the code, so now you just have a bunch of broken code in here that's kind of missing things. But this is one of those creations that if I make it right and make it working okay, I probably don't need too many more versions of the drone, just something that can get the job done and supplement my larger creations. We're slowly getting there. I will be taking this microcontroller for altitude hold and applying it directly into the drone microcontroller. Now, I did clean a lot of the things up in here, so it should work a lot better. And in addition to that, I did add some of those other features. I'm talking about the camera mode. So now in this case, we can actually position the camera in a place that kind of works better for us. Now, because the lack of sensitivity, it does kind of take a little bit of a delay, or it does have a little bit of a delay. So I do have to figure out maybe a way to make it a little bit better. And also see this, when this thing shuts down, this should also bring it back to the ground. I added a bunch of features, including if this is on but not connected, it actually won't spool up, like the propellers will not go. And then if I hop in here and turn it on, only then will they turn on. And actually this is a nice feature, because if we take off and I lose signal, it will come down. So it's intended to come down if it loses signal. Yes, it can be in the water, and that's unfortunate, but it is what it is. So now the last thing is that hover. So you can see here, I actually do have a collective. It's slowly dropping, but it should start hovering rather than continuously going up. And I don't have any trim on the seats or anything like that. So any collective is coming from something else. So I just have a little tooltip here with the collective, which is channel 4. I added a second little tooltip here. So the in and out, the out is what's going to the rotor. The in is what we are putting. So we are putting 0, but I still see it climbing up. So I definitely don't want that. I'm going to bring it down, force it down here. Oh. Interesting. Now with everything connected properly, you can see here the collective out is -0.3, and that's pretty much what we have if it loses connection. So if you're flying up and you lose connection, it becomes negative 0.3, it comes down, and these shut off. But in addition to that, there is now the altitude hold. So you could see here, we're holding the altitude. Now you saw how it kind of sprung up. That's because I didn't put a reset on the altitude hold. But you could watch the elevation here, and you'll see that it's hovering quite nicely. Now if we pitch ourselves forward, that may change a little bit because we are pitching forward, but the idea is that when you let go, it should make its way back to that 10 elevation that we previously had, and it should stay there. Maybe it dips up a little bit. On the camera mode, you can see here with the arrow keys, you can position the camera as needed. Now I just have to kind of see and determine that it stops, opposed to kind of constantly moving, so that's not what I want. But it does give us a nice control over the camera. Now that should not be changing, so that's another little bug. Alright, so now if we turn on camera mode, it shouldn't affect what we see on that throttle, but I did let go and it's still moving, so we don't want it to move that slowly. I'll have to take a look and see how I can fix that. It's a delay, and it's kind of just because we do have this unfortunate setting here on the seat, but it's kind of necessary. Anyway, with that done like that, you could see it's holding the altitude, which is really nice. And if I turn that off, the helicopter started to spin because of the previous number, so that's actually very funny and unfortunate. So it's like shooting up. Okay. The altitude hold is reacting too quickly from what I see. So this should be a little bit more stable, hopefully. You can see we're rising up, and then if we stop and let it kind of settle back down to 0, it should hold that altitude. And if we give it forward throttle, ideally it keeps holding the altitude. Now it did drop severely for a second there, so that's quite interesting. And now it seems to be quite stable. You can see here that if we kind of let it go, we get that nice auto hover. And I actually removed this, like it's still showing up here, but I'll change it because now pressing 1 on the seat hotkey and 2 moves it left right, 3 and 4 move it up and down, and 5 just resets it. So it gives you a much easier way to control the camera without having to, pretty much without interfering with the ongoing operation, because now I can pan it and move it while I'm still flying the drone. I don't have to go into a separate mode altogether. So it is nice for that. I do kind of like this actually, and that will reserve this for future attachments and things that I'll see whether or not they end up being implemented. Obviously these are great features and functions on this side. These ones I'll see what I end up doing, but pretty much that gives us a pretty nice stable drone experience. Yeah, it is not too fast, it's not like a speedy thing, but it should handle okay. Oh, I spoke too soon. It did a flip but recovered. So that was us going down and pitching forward. So I will go into more tests. So, oh, there it goes again. But pretty much, if you do limit kind of crazy movements, it should work itself pretty nicely. It really seems to be the combination of effects, like if I'm pitching and rolling and going down and then drastically changing, that's when it kind of goes all funky. And funny enough, it does seem to catch itself. But that said, it isn't a good experience to be trying to land and getting that type of thing happening. So we will see if there is another approach, or do I just have to kind of limit my my buttons. Maybe just the simple clamp will prevent kind of crazy movements, but it does seem to handle pretty nicely, all things told. With a few little hiccups, you could see that kind of jumping up and down. So overall, I mean, pretty user-friendly and pretty controllable, with some small issues here and there. I've done two things. I eased off the changing of the throttle, or the collective, and in the words of Lord Bison, one of my Discord server admins, he said, if you drive it like you stole it, then you kind of have to accept there's going to be some issues. So it is a user error if you fly the thing around like a one of those drones that kind of go through buildings and stuff. It is intended to be more flown slower than that and just kind of more stable. It's more intended to be a viewing drone. Now, I will see if that can change, if anything can be done on the front of the actual microcontroller. And one other thing is, when it touches down, it should hit that contact pad there and stop it. So that is one other thing that I kind of tried to do. So if this actually drops down like this, that should reset. It doesn't work, so I'll take a look at that. Another thing I've done is XML modded the propellers ever so slightly, or rotors, so they just end up being a little smaller. You see, this is their smallest size, like this, which kind of stick out past the actual drone itself, which makes it a little inconvenient for the Unicorn style. And like this, they more or less fit the envelope, so that is pretty nice. I'm quite happy with this approach here. So overall, I'd say the shape is, while ugly, it works. I've made some changes, including XML modding the rotors just a little bit, just to give them a little bit smaller of a size. Now you can see the whole thing's going up. We should have it stop. Some kind of auto hover, so this is very good. And now if we push it forward, we should go. Now I did add a ground height or elevation, so that does tell us how far we are off the actual ground, because of course the elevation doesn't consider mountains and other obstacles. So that is one of the other things that I kind of wanted to do. You do see I did sort of make it a little more, call it slower, but if, in the words of Lord Bison, one of my Discord server admins, if you drive it like you stole it, you can expect that it will crash. Obviously, you have to be very, like, patient and kind of, like, feather the controls, if you will. So you can see now the ground is 18 meters, whereas the elevation is 44. So we're over top of the hangar roof here. And like Lord Bison said, so if you have full-on throttle up, and then you quickly throttle down, it worked, but not in every case. And if I quickly hit up, boom, it flips. So you do want to minimize kind of quick changes, and I may make a manual kind of, or rather code in something that prevents quick changes like that. But I do think user error plays a large part in something like this. So if you do learn how to use it and feather the controls, then you should be okay. It's really if you tend to, drive it like you stole it, then you'll end up having issues. Now, I do hope that, so I do want it to not do that. I do want it to drop down and auto hover over the ground if we do touch down, or make it such that, like a real drone, if it touches down, the propellers turn off. So that is one of those things that I will have to look into. I do like the auto hover at a nice, like, 9 elevation, but is that 9 elevation auto hover here, or is it going to try to auto hover at 9 elevation even if we're on a mountaintop and we're actually at 50 elevation and it's going to try its best to go down into 9. For visual purposes, I want to show you kind of the difference in the coding. So if I do hit this, you'll see the propeller sizes increase to what was 0%. So I actually set it to negative 50%. So it does give the Unicon box a bit better of a clear envelope. So the idea is that if you are storing it, then it's kind of the same size, more or less, as your Unicon. It's quite fun building in all these safeguards, like if this is off, the thing shuts down. That's a nice feature. Other little things like that. So I do want it to be user-friendly still. I don't want it to just be, you know, making its way and being like difficult to use. So what I did, I actually changed the altitude sensor now to auto hover at closer to 1. Now it's using 1.5, which is interesting here, but the idea is that it is a little bit better rather than being too high up. Now if I make its way down like this, that should reset the thing and land it, but it does want to go up. So what I'm going to do is inside the microcontroller, I'll actually change it. I'm going to add some things like my real life drone. I do have a DJI drone. I do want to make it such that if it touches the ground, it'll actually shut itself down until you press throttle up. Also, to give us a little bit more control, I did actually put decimal places. So we have 1 decimal place for the elevation, for the speed and the ground. I don't need the 1 decimal place for the actual distance. I think that may be a little bit overkill, especially since you're going to tend to take it kind of far. But it does seem to be working still, so I guess it doesn't hurt to see how far you are going and even the speed and rate at which you're moving away. So the decimal places for sure do help. I may even look into doing this on the ROV version itself, but yeah, that kind of works. The color scheme is from the ROV version, which are yellow, kind of underwater, but in this case, they may be the contrast may not be great, but I think you can figure it out. So I'm not keen on changing it too quickly. Wow, I really do like these decimal places though. I'm going to do a quick check to see if with higher numbers, the decimal places don't clash with anything, specifically with the distance in the bottom left. When we hit 1 kilometer, what is going to happen? And you could see that we've kind of climbed to a nice level here. We're 120 meters above seafloor, and now it should stabilize itself at that elevation as we go. So I'd say the elevation hold is working pretty well. See, that is not what I wanted. We don't want that to fold over to the next line. So that's where I do the tests, and that's kind of why this is all important. Of course, other than a practical test in the game, Pony IDE gives us a perfect example. I did balance this distance there, so now everything seems to make a little bit more sense here, and this seems to be like properly shown. I do see that there's this number there, which I can't help but wonder, is that part of the laser? Like if I have a laser mounted on the thing and I shoot it, it tells me how far something is. If so, it may be cool to make kind of holding space, turn this laser on and hit a distance so you can calculate things, you could see how far things are, that type of thing. So I will see if I can make that work. You could see here that it is number 6. So number 6 is laser. Cool, I actually do have it already in the code. For one, I don't really want to make this microcontroller any larger than I have to. So putting the laser may not be in my best interest, but one thing to keep in mind is 4x4 isn't really centerable on the drone, whereas if it's 3, I can have it kind of centered. So if I do place some of these like this, it actually gives me 2 other nodes that I could work with here. Ultimately, I'll see where all this takes me, but one thing I'm not not really looking forward to is if I do have a laser, which is useful for pinning things and kind of telling distances. The one thing I don't like is I will have to, in the drone itself, have the laser, and then also it'll have to be activated by button, etc, etc. So I'm probably just gonna skip it for now, to be honest, just to kind of see, because overall I do like where everything here is headed, and putting, you know, changes, attachments, stuff like that, it may be in the cards later on. Currently in the code, I have something saying that if the button is on, like the drone is on, and we have connection to the remote, then it'll have throttle, and it will pretty much spool up. But I do want to add an SR latch in here now, saying that if we have throttle and we're connected, or sorry, if we have the power on and we're connected, but now if we also put in forward, like up collective, then it will enable this to come on. Now I just have to find my collective, but pretty much those are the factors that will be turning the thing on. And I think the collective is somewhere in this mess with the drone stuff. So here it is, collective, and if I just trace that back, I should be able to find this, which is my actual input on my keyboard. So if this is going to be pressed, so we just need a threshold gate, which I actually think I have one up here for the clamp up there. But in essence, if we press up, there's a threshold gate, but it's set to 0, which I don't want. I want this one here to have something like, if it's between 0.1 and 1, that's when we're gonna enable our SR latch that's over here. So if we have that, and we have the button on, and we have connectivity signal, then we'll pulse, and this SR latch itself will turn on. Now, if we touch the ground, that's the second part, which is up here with the altitude sensor. If we touch the ground, then I want it to stop it. Altitude sensor may be down here, actually. Nope, it was up there all along. So here we go. Distance sensor on the bottom. So in this case, if we're between 0 and 1, maybe that's a little too high. Like maybe we want it to be 0.5, for example. But let's see, try this. Let's try 0 and 0.1. And I do want to pulse, actually. Well, no, it could reset it. Let's just see if this works. Moment of truth. All right, so we're going to turn it on. We have the channel, and I'm just going to push this. So we're going to turn this on. Okay, we have the connectivity green. Fantastic, and it's not flying. Now, if I press up, it should turn on the SR latch, but it does not. So there's something I have to look into. And I do think that I'm a dummy, because I should have used a pulse, because without the pulse, what's happening is, because we're at 0 altitude, it's constantly resetting it. I just want it to be a single hit of resetting rather than a constant always resetting. So now if I turn it on and turn this thing on, good. And if I hit collective, beautiful. All right. So now, even though we're at the ground, it should take off. And because I set it to 0.5, hopefully we can hover around the 1 mark, just like this. Amazing. All right, this is actually very, very good. And now, in theory, it should hover indefinitely here. If I bring it lower into this range, it should power itself down. So it does not reset itself. Oh, it does, but it just takes a little bit of time. So I'll have to dig into the numbers. It may be that it's still trying to work, because of course my throttle here isn't instantaneous. There is a little bit of a sensitivity issue. But let's try this. So we take off. Okay, we're happy. We're flying around. And now we want to land. So we come to the ground. We do this. Does it stay on the ground? And does it shut itself down? Is the best question, actually. Well, it doesn't appear to be lifting off. And the RPS is draining, so that's it. It is shutting down. Yay. Alright. That is awesome. So that's that. What I will do is obviously change the aesthetics of the drone, but I'll do that kind of on my own time and at my own pace. But programming, coding, making sure the thing works, giving it all these kind of safety features and functions and whatnot, that is what I wanted to showcase to you guys, because while it is a bit of a overwhelming project, if you will, it does utilize a lot of the previous coding that I did for the ROVs, and with that in mind, you actually can end up pretty much giving yourself something that is its own project, really. It does use some of the same components, but it ends up changing it up enough. Now, I do have to play around with this, the attachment button and stuff, but overall this stuff does work, and there's a lot of other functions and things that can be added, such as transporting of things and whatnot. A lot of different options, and this will be perfect for the next vehicle, the next large ship that I have in mind. So that's a little hint for kind of things to come. Thank you all for watching. I do, as always, want to thank all of my YouTube members and my Discord server boosters, each and every one of you. Really appreciated. Actually, I just released a few new creations for them, including a beta version of this drone, so they are able to enjoy things like that. And I do want to thank each and every one of you for participating, for being a part of the community, and for encouraging me to make these videos and kind of, I don't know, it's just really nice to have a community that is the way you guys are with the building and engineering stuff that I do love. So I do appreciate that, and I am very excited for things to come, for the next videos, for the next creations. As I mentioned, I do have a lot of different plans, and with those plans I have a lot of things that are going to be coming. So stay tuned for all those, and as always, happy Stormworksing, everyone. I will see you next time.